right, let's move into the topic of subnetting. So what is subnetting? Well, this is what makes IP addresses hierarchical. The process of dividing a network into smaller or larger network portions or sections is called subnetting, IP subnetting. It can be very, very useful for many different reasons, and it can actually help us to isolate groups of hosts together easily. As we discussed previously, each address space is divided into a network portion and a host portion for class A, B, and C. Just for review, as an example, this would be the network portion of a class C address, and .15 would describe the host portion. So by default, every network has only one subnet. So within that subnet or network contains all the host addresses that are defined by it. So when we talk about this number right here, the subnet mask, it defines what the host addresses are going to be. And the net mask is basically just a number or a specification in binary of the amount of address bits that are used for it. Now remember, each bit is considered significant when it is a 1 in the net mask. For instance, we would express this address 192.168.0.15 in binary like this. And as you recall, when we reviewed this in our IP addressing section, we decided that each of these bits in an octet has a value position, right? It's either on or off. So if we want to describe the network portion for a class C, the first 3 octets are the first 24 bits. So the net mask would be expressed like this. And that binary expression of that net mask, subnet mask, in decimal looks like this. Any bit that is a 0 in the binary representation, which would be these bits here, right, are the host portion. And they can be changed. They can be turned on, they can be turned off. These bits don't change, network bits. So I wanted to bring up the ANDing operation that I learned, subnetting, and it went right over my head when I first learned it. But ANDing basically is an operation that says, I'm going to save part of the network address and I'm going to discard the host portion. So again, this is expressed as 192.168.0.0. The host specification is a difference between the original value and the value of the host. In this case, the host was .15. So this concept of subnetting is taking a portion of the host space of an address and using a host portion as an additional criteria. So let's take the example of a net mask of 255.255.0. We remember that that was 254 hosts, right? So this is the network portion. This is the host portion. This binary representation is 15 right there. So if we change our subnet mask just by 1 bit, we change it from 24 bits, and now we change the network portion 1 additional bit, 25 bits that are on, right? Well, that new expression of the subnet mask would be this. So we've actually made the host portion smaller, right? By changing the network bits just by 1. So what we've done is by turning this bit on right here, we've taken this network portion and we've just cut it in half. Because what is 128 plus 128? 256. Isn't that how many, including 0, that we have as our block size when there's 24 bits on? So do you see how I've literally cut this network right in 2 by just moving the network bit to the right and turning it on? That's subnetting, guys. And the real power in subnetting is how we change these network bits. Because of the power of manipulating the network bit, they actually came up with a name for it, and they call it CIDR notation. CIDR means classless inter-domain routing. Originally, it was developed as an alternative to subnetting. What it's become is the definitive way to subnet. So CIDR basically takes this expression, 255.255.255.0, and expresses it, that IP address, like this, with a /24. Well, what does the 24 mean? It means that for a 255.255 network, the first 24 bits are on. That's all it means. So /24 means these first 24 bits are on. When we turn this bit on right here, what would the new CIDR notation become? / what?
12.
25.
Oh.
So we went from 24.
Oh.
25. So all this is the network bits that are on. That's it. This allows us to do something very, very powerful in subnetting, which is called creating something called a supernet. A supernet is a more inclusive address range that is not possible with traditional subnet masking. how traditional subnet masking was taught was strictly by the class A, class B, class C concept. /8, /16, /24. Because they didn't think they were going to run out of space. So they had to have a way of extending the range of these networks. So with the traditional way of subnetting, this expression and this expression couldn't be combined. However, when we use CIDR notation, this changes this from always being a /24 to something that looks like this. So what have we done here? Instead of 25 bits, right? We've turned the last two off, and now we have what? 23 bits. When we move it to the left like that, we are supernetting the network. When the network bits move to the left, we are creating what we call a supernet. And that, again, that /23, this is what it would look like. So that whole concept of traditional subnetting and CIDR, I mean, it went completely over my head, but I wanted to introduce that to you. And that's when I started to create my own method of doing it. So my method of subnetting, IP subnetting, is by using a formula that I developed when I was first learning it. And it literally is a set of steps that are foolproof and determining what the network and broadcast addresses are going to be for any given network or any IP. If you have an IP address and a prefix, this will work. So here is the subnetting chart that I developed. I'm not sure this works still. Yeah, it does. Cool. Oops. It basically gives you a visual representation of what we've been talking about with IP addressing and subnetting so far. Now, you remember this guy right here? This dude? Remember him? All I've done is take this left to right visual and basically flip it. Let me show what I mean. And this is what kind of turned the light bulb on for me. You see how I've taken this left to right visualization of the binary and I've just stood it up on its head. on the far right. Right? These block sizes on the far right of my chart are the most important factor. It's not to minimize these other block sizes. And do you notice something about what the block sizes do?
They shrink.
When they go up like this, what are they doing?
They increment.
By what?
By 2, or yeah, by the power of 2.
They double each time. They double. So 128 down here becomes 256, and 512. I'd round it off because the number would be too big for my chart, but I continue it right here. 1024, 2K, 2048, 8K, 8192. So 2 to the power of 0 equals 1. Would that be the math in decimal? 2 to the power of 0 equaling 1? Nope, this is binary math. All the way up to 4,294,967,296 possible addresses. You also see on the far left over here is the CIDR notation that we just talked about. Many times you'll hear the CIDR notation called a prefix, a network prefix. And that's all these are. These are the network bits turned on or off. So with one network bit on, that's going to be in the first octet. That's what this first means here. There's always 8 bits in a byte, right? So in the first octet, I can have 8 of those bits on. Second octet, 9 through 16. Third octet, 17 through 24. Fourth octet, 25, all the way up to all 32 bits being on. So this makes it very flexible. Do you guys see that?
That's now.
What's that?
That makes more sense now. I was watching this for a while. I was like, what's... I mean, I was understanding it, but now I get it on there.
Yeah, I mean, this is, Eddie, this is exactly what happened to me, man. I mean, the light bulbs just started to go ding, ding, ding.
I get it now.
I also give you the value, the decimal value in that first position. So in the first octet with 1 bit on, the first octet is going to be 128. If all these bits are on in the first octet, that's 255, right? With the prefix of 9, the second octet's 128. 17, third octet becomes 128. 25, the fourth octet becomes 128. Make sense? So this chart becomes huge for you to memorize. We'll practice it. That'll be your homework this week, is practicing drawing it. Because all they give you is a whiteboard and a dry erase marker and an eraser. So always ask for 2 whiteboards. I haven't found a place yet that has denied me that. Ask for 2 whiteboards. First whiteboard is for you to write down all the stuff that I'm teaching you. So you'll write down this chart, simplified. You actually will not need this portion right here. You won't have to write it down. Not needed. And the reason for that is on the Cisco exam, they never get higher than a 32,768, 2 to the 15th block size in their questions. They really don't get into these ranges up here. Because a network that size is pretty rare. But you will need this and these. You also will need to write down the powers of 2 up to 2 to the 15th. These powers here are not needed. Okay. Do you guys remember the parts of this chart that you need to memorize and practice drawing? So that'll be one of your homework assignments this week to practice that. All right. Now comes our formula. Let's go ahead and open the subnetting chart in a different window. And let's put these side by side. We're going to need them. Now comes our formula. Let's use this following IP address. And that's actually this link right here, subnetting formula. So in the lecture, I say, use this IP and this prefix. We understand what a prefix is now, right? So step number 1, and this is what you're going to eventually have memorized in your mind. And so this subnetting is just going to be cake for you guys once you have these steps down. Step number 1 is identify the IP and the network prefix. So George, what is the network IP, or the IP address and the network prefix? Can't hear you, George.
Oh, sorry about that. I was muted. All right. So can you go ahead and repeat the question?
Yeah, what is step number one says identify the IP address and network prefix. What is the IP and network prefix that we're using, George?
Okay, so the IP is 70.107.23.22, and the prefix is the 11.
/11. Always
Slash
remember to say, yep, always remember that /11 too. So I give you some help here. That's the IP, that's the prefix. If we're going to change that /11 into a subnet mask, this is what it would look like. 255.224.0.0. Let's see how that equates over here. /11 is right there, right?
Mhm.
Which octet is that?
The second.
See how I found my number? I found this prefix. That's the first thing my eye looks for. And then I went down and I saw that it's in the second octet. Next thing I look at is this number, 224. So if that 224 is going to live in the second octet, do you see that the first octet is all ones and that the second octet is 224? And how many bits are on in the second octet? How many ones?
On the second octet?
Yep. We know the first octet is how many?
Would it be 8?
First octet would be 8, yeah. So how many bits are on, network bits are on in the second octet?
Oh, on the second one.
Well, let's see, 11 minus 8.
11 minus 8. 3?
3. 1, 2, 3. 3 bits. So what would that look like? 1, 2, 3, 4, 5, 6, 7, 8. Dot.
1,
1,
2.
2, 3. Right? And how do I get 224? I add up those 3 bits. 128 plus 64 plus 32. These are all on, which equals 255. Got it?
Yeah.
And there it is. There's the binary that we just talked about. See it? /11.
Uh,
8 bits in the first octet, 3 bits on in the second. Okay, what do we do next? Step number 2. Eddie, tell us what step number 2 says.
Determine the block size from the far right column.
Far right column of what?
It says from step 1. Determine the block size from the far right column. Right here, the fourth octet.
In the table above,
Yes,
which is the far right column?
it would be the one that says fourth octet.
This one right here, right?
Yes.
Didn't I also say that was the most important column on my chart?
Yes.
Remember? So if you forget, and trust me, this will trip you up. If you forget that in step 2, we're considering the block size only from this column, because there's 3 other block sizes, guys. There's a block size here, block size here, block size here. So always remember in step 2, you go to this column for this calculation. And you line up that value with the signer notation in one of the 4 columns to the left. So we see 11 right here, right? So for a /11, what is our block size?
32.
32. What if it was a /19? What's your block size?
Still 32.
32 in step 2. Step number 3 is a little bit tricky. We have to determine which octet we're working in. Is it octet 1, 2, 3, or 4? Remember how I had those listed here? 1, 2, 3, 4.
It'll be octet 2
Why?
because it's second on your graph.
No. Why is it octet 2?
Oh, because it's the second.
Because that's where the /11 is.
Yeah.
Because it's more than 8 bits. So it goes
No, we don't even think bits and bytes and all that. It's the second octet because that's where the 11 is.
Yes.
Period. See how your mind tries to inject additional information? Simply put, step 3 is what is the prefix? What octet am I in? That's it. And because it's the second octet, I now underline the 107. Because the 107 is in the second octet. With me? Next thing I do is I take that value and I'm going to actually show you how this kind of looks when I do it. Let's see, how can I do this? How do I get a whiteboard out here? We'll do it here instead. So we have 70.107.23.22/11. So out to the right, step 2 was what? Determine the block size, right? We determined it was 32. Then what do we do next?
We discovered that the 11 falls under the second octet.
Yep. So let's do that. Second octet, right? The next step is we take this number, 107, and we bring it down. $32, oops, and we divide it by, or 107, we divide it by the block size. Oh, I did that backwards, sorry. We take 107 and we divide it by the block size. Now the old way of doing that was what we call long division. I don't know if you guys remember long division. And it basically did this. Sorry. Remember long division? That's basically what we're doing here, is long division. So basically, how many times does 32 go into 107 is basically what we're saying. 3 times and some change, right? So we always disregard any remainder on this step. And we round it off to the value to the left of the decimal, 3. Okay? Still getting used to Zoom on this. So we take that value, 3, and we bring that value down here, and we multiply it. Okay, that's what I should have done there. Bring that value down. Multiply it by what?
By the block size.
By the block size. And that equals 96. So I take this value, 96, and I insert it into the second octet of my IP address, this octet right here. And then everything to the right of the octet becomes a 0. So what is my network address that I've discovered from step number 6? It's 70.96.0.0. So in the spreadsheet, you would actually, there's an N here with an equal, right? You need to put 70.96.0.0. Next, you with me so far, guys? Eddie, you okay?
Yeah, I still have to see a little bit more. I mean, I know how the formula is working out and how
Yeah, you're right. We'll have to see some different ones too.
yeah, but I get the formula. It makes sense.
Okay, cool. And that's what I had to do. It's like, wow. I just had to trust the formula from the beginning. So then I add the value from step 5, which is 96, right? And I add the block size to it, which gives me what? 128. Well, because we're trying to determine the broadcast address, we always have to subtract 1 from that value to find the number that we need. And that makes it 127. So we take that value and we plug it where? Into the second octet. Instead of all zeros following this number, we actually turn on all the host bits to 255, 255. And now our broadcast address is what? 70.127.255.255. So how big is that network? Because isn't that a network? How big is that network?
It's 65.
We can tell exactly. And this is where the other block sizes come into play. The /11, right? Second octet. Well, let's look at the block sizes in the second octet. Basically 2 million. Do I know that exact number? I sure do. This one right here. 2,097,152. No, that's the block size. What do I have to do to get the number of usable hosts?
It's 150.
2 million. But there never is any guessing about this, is there? $2,097,150 hosts. What is the first host?
The first one is 796.0.1.
Yep, that's the first place that we can assign an IP address. Typically, that's going to be the default gateway of the router.
Cool.
What's the last address we can assign? 70.127.255.254. Because 255 is what? The broadcast. And 0 is what? The network. Okay, use them. They're reserved.
Okay, so this is to set up a network. Like that's the range that you have to work with.
That's right. That's exactly what I did when I built this network right here. In fact, why don't we apply my formula to it? Should we do that? Okay, what's step number 1?
Identify the IP address and capture the prefix.
All right. What is it?
192.168.1.37.
Slash.
255.255.255.0, which is I want to say 24 if I'm not mistaken. Let me check.
What's your chart?
That would be 24, yeah. 32.
This guy right here, wouldn't it?
24, yeah.
Because all 3 of these octets are all 1s.
Yeah, 24.
Okay. Yeah, there's no guessing with the chart. Why you need to memorize and write it down when you walk into the exam.
Yeah, this looks more important.
Okay, what's step 2? What do we do?
Determine the block size.
Okay. What is the block size?
1.
You sure?
No, isn't it 256?
Okay. George says it's 56. And Eddie says the block size is 1.
Totally off of that. For sure.
Which one is right?
I gotta see that.
Let's look at our chart here.
Yeah, I gotta see that chart.
24 is right here, right?
Yeah, it's a third octet.
So we always go to which column to read in the second step?
First column.
All the way to the right. The block size is 1.
Yeah,
I thought we did that step 3, not step 2.
No, it's step 2 that we go to the far right.
Yeah.
Oh.
Right there. Why I slowed down and said that. Block size from the far right column. Right?
Yeah.
It's tricky, doesn't it?
Oh,
See,
you get
see why you have to stick to the steps and the exact wording of the steps? Okay, what's step 3, guys?
determine the octet you're working in by looking at one of the 4 columns to the left. So
Block size equals 1. They're asking you to determine the octet, right? Which octet are we working in?
The third one,
How do you know?
because
right there on the chart.
yeah, it's the third 24 is the third octet or
Guys,
prefix.
the
Yes.
prefix is everything. You see that?
Mhm.
When you know the prefix, you got everything else, man. 24,
Mhm.
third octet. Well, since we know that we're working in the third octet, this one right here. What do we underline?
It should be the same as the 256.
No, on the IP.
Oh. 1
Why?
is the third.
That's the third octet.
Mhm.
We underline the 1. Right? Okay. What's the next step?
Next step is to divide the octet value obtained in step 3 by the block size.
All right. So we have to bring down this 1, right? And divide it by the block size, which is what?
1.
1.
1.
You get a 1. 1 times.
What does that equal? What does that equal?
1.
Equals 1. All right.
You get 1, and then
Step
you
5.
multiply.
We add the block size to it.
Nope.
Well, you multiply 1 by the block.
Adding is the other step.
Oh, you have to multiply 1 by 1.
Okay, so we take the value obtained from step number 4, which was what?
Yeah, because it didn't get any of the, you
So we
know.
bring it. See how I'm bringing it down?
Yeah.
Right. Take that value 1 times the block size.
Times 1.
What does that equal?
That's 2.
No.
1.
1, right? 1. Sorry. In the brain went away.
1 divided by 1 is 1. 1 times 1 is 1.
Yeah.
All right. So step number 6.
Take the value from step 5 and place in the second octet position first.
No, that's from the other problem. We're in the third octet.
Oh yeah, right. From the third octet position.
Okay, so we take this value right here, right?
Yeah, the 1.
And where do we put it?
In the third octet.
So we're going to put it here,
There's the 1.
right?
Mm-hmm.
Well, guess what?
Already 1.
It's already there. So since it's already there, did we accomplish that step?
Yeah.
Yeah, we did. Now what do we have?
Now we have 192.168 1.0.
Yeah, 1.0.
1.0. And that's our what?
Our network address.
Network address.
Cool.
Okay, what's next?
And this is when we add the value obtained from step 5 to the block size and then subtract that from 1.
Okay, so we need to take the value from step 5, it says.
Which is 1.
Bring it down here, right? 1. A lot of 1s in this problem, isn't there?
Yeah.
What are we going to add to it?
The block size, which is 1 as well.
Okay, then immediately what are we going to do?
We're going to add it, and then afterwards we're going to subtract 1 from that. Which
Well,
is
that
back
equals
to
2. When we subtract 1 from it, what does that equal?
1.
Man, we keep landing on 1. That's a problem.
So
Formula going to work?
address is 192.
Hard to wonder if this formula is going to work or not.
1.1.
So we take that value and we assign it to which octet?
Should be the 3rd octet.
Why?
That's the one that.
It's one we're working in.
Yeah.
So we assign it right here.
It's 1.254.
Well, it's already 1. So have we been able to do that step?
Mm-hmm.
Sure. Well, what's our broadcast?
192.168.1.255.
That's exactly right. Did it work?
Yeah.
It's kind of a funky one, right?
Yeah.
But if you stick to the formula, guys, it'll work. Now, to check your work, because I'm not always going to be around, you can use, this is a hyperlink in this PDF file. This will take you to the CIDR calculator. So if we really weren't sure, we can do this. The only 2 things we need to worry about is putting in the IP address, right? And setting the prefix, which is what? 24.
Mm-hmm.
So here's our mask. There it is. Here's our block size. Right here, 256. So we're in the 3rd octet. Isn't that our block size? Maximum addresses basically means the host addresses. So we always have to take that block size and do what to it?
Subtract 2.
Subtract 2. So here's the network address, 192.168.1.0. Here's the CIDR notation with it, 192.168.1.0/24. Here's the range, 192.168.1.0 through 192.168.1.255. Pretty cool, huh? Kind of neato. Let's see if it works here. Let's see. Let's see if this works. Right? And what was our mask bits? 11, right?
Yeah.
Our CIDR net masks, 255.224.0.0. 2,097,152. Maximum hosts, 2,097,150. Here's our network. Here's our range, 9600 through 7127.255.255. So if you get stuck, don't freak out. Just go back to the formula.